Good evening, sir. Atunji.
Good evening, Irve sir. You are quite an attentive candidate and coming every day. Thank you very much for that.
Look at your smile, sir. Astonishing.
Okay, so let's start with our presentation. We are already about 5 minutes into it. So today we will start with the blockchain platforms for commercial applications. Yesterday we saw the business needs, and today we will see what are the various needs for commercial applications of blockchain. So I think 1 second, let me just put off my video so that it's a little better for all of you. Yeah. So as usual, we'll start with a recap of what we did yesterday. Incidentally, Tigray sir reminds me that people have to do daily quizzes and you are supposed to get marks for that. So here is your daily quiz. What all we did cover yesterday and what you know about it. So those who answer or chat there, they will get marks. Those who don't, they don't get marks for this quiz. So everybody can contribute somewhere at least in terms of what they understood, what they followed yesterday. Again, my objective here is to know what you understood out of it rather than what I covered. So I would like to know that from you. That what are the things you understood out of any of these topics that we have covered yesterday? And whether you find them useful, whether you find you are more interested in working further on that, if you have any idea what you're going to do on it, and so on. So who would like to start except Hidwe sir? I hope you remember all these things that we covered yesterday. Any doubt about that? No? Okay, if there are no comments, then I would also prefer to be silent about it, assuming that you have followed or not followed, I don't know. But let's go ahead. Anyone else wants to make any comments, including Hirve sir now?
Okay. So we started with private and public blockchains, business features in these blockchains, then 4 layers of blockchains.
Yes.
And we had, you suggested a video, digital twin in industry 4.0. So I saw 2, 3 and they were very interesting.
Mm-hmm.
One was on Siemens, another one on IBM.
Yes, the digital twins.
Yeah, digital twins. So
Right.
very interesting and thrilled to watch.
Yes, that's an interesting technology coming up. I do train people on Industry 4.0. That's a separate topic. But yes,
very good. So maybe we can have it at SVERI.
We had a workshop, 5-day workshop at SVERI last year on Industry 4.0 for a lot of faculty. I think more than 70 faculty attended it.
I see. Maybe I was not here that time.
Yes, you were not.
Matter. So
but yeah,
let's see. This is quite interesting. Then we had seen the video from Jaspreet Bindra.
Yes,
and that was an eye opener. He covered most of the topics that people talk about blockchain in just about 15-17 minutes. So that was a really good one.
Yes. He talked of a lot of applications also, typically in the agriculture sector and rural electricity, and those might be very interesting for the audience right now.
Yeah. And then you had a small debate on what was happening, or what are our contributions to that. And then there are 4 pillars of the summary. That's what we did yesterday.
Yeah. Okay.
You told us to check the IBM.com.blockchain, but probably I was too tired. Supply chain, right?
No. I said you search for IBM and Merck or IBM and Walmart for those application examples. IBM.com.blockchain is a very big, vast area, and it will talk a lot about Hyperledger and other products. We will cover Hyperledger today.
Okay,
so you
great.
Will see something that IBM has. That's an IBM.
You suggested Walmart, right?
Yes,
I did
Walmart is
not
the supply chain
had time to
example, and
look.
Maersk is the shipping example.
Yeah, okay. Maybe I will
International
have it
trade.
today night. Today night I will have a
Yeah, we
look.
saw a short video on that, but
Yeah,
IBM
we
and
saw.
Walmart, you might see a lot of literature and other details about that food trust and what they have created. Okay, so those are
Excellent.
interesting things. People can look at them. And I think let's continue with our session today. We have a short session today for 1 hour. That will be followed by Mr. Ishan from Seneca College, Canada, who will be talking about fintech applications of blockchain. So that is we have after 1 hour. So today what we will cover is we'll cover basic application framework for blockchain. There are 2 or 3 important frameworks like Hyperledger, Ethereum, and Corda. And there is a bank chain which I explained to you yesterday, which is the chain for banking network. They do something on Corda or R3 as it is called. So that's a separate platform for most of the banking applications. But today we will cover Hyperledger as one of the platforms. And I find that Hyperledger has a lot of good training material available compared to Ethereum. I have a bias towards that in terms that I have worked with IBM for 16 years, and I think IBM is a very great company as far as training materials are concerned. So Hyperledger, understanding the concepts, teaching, I find it much easier. Ethereum, I tried to do that, but it's not so well documented, I would say. But yes, there is a company called Consensus in Canada, which has a lot of training on Ethereum, and it's available now. And our friends in Canada are more comfortable with Ethereum compared to Hyperledger. So I thought some of them might be able to discuss more with you on Ethereum products and how to use Ethereum. So I did not want to cover that. So today we will plan to cover Hyperledger as one of the application frameworks and see how commercial blockchains work. It's like using a database for applications rather than wondering how a database works. We already saw how that works. So if you look at the various platforms available, the public platforms are Bitcoin, which was the first one, Ethereum, multi-chain, open chain, Quorum, and BigChain DB. Quorum is another platform which is quite popular among banking and some other applications. So you might look at that. And in commercial platforms, we have Hyperledger, Corda or Ripple or R3. All 3 are similar. Then IOTA is one interesting platform which talks about how blockchain can be used to connect machines on the internet and how machines could connect with each other, and not only connect, they could transfer value. So if a machine does a job for some other machine, then how can you make a payment on that? So it's an interesting concept of using its own tokens, but there are no 2 persons here. So everything works on smart contracts there. And if robotics machines start talking to each other and do services for each other, that's the way they are thinking about and how they can contribute. So IoT is that token, I would say. Then you have chain code, gospel, Tezos, block one, and many other. So all these commercial platforms and public platforms, the names keep varying a lot. A lot of names keep adding and they get deleted. But I would say Hyperledger, Ripple, IOTA, and Ethereum are the more stable ones. And of course, Bitcoin. But then all others are like we never know. For example, EOS.io was one of the names which I heard in May 2019. That's hardly, no, 2020, I think, or no, 2019, 1 year ago. Then people were saying that this will replace Ethereum, and but later on, what happened with EOS.io, I don't know, but nothing much happened. But there was a company in Pune, and I know that person, Uday Kothari, who is a CEO of that company. He told me, no, actually, Ethereum is not going to last now because EOS.io will come. But Ethereum has recently announced something which I will share with you a bit later. So I believe that Ethereum is still going strong. Some of the other contenders are not done. Okay, the various programming skills that you require again. Now here, yesterday also we covered some skills required for blockchain applications. Now I am covering more from the specific application point of view. For example, if you are interested in working on Bitcoin, Ethereum, Bitcoin Cash, Ripple, or Litecoin, then C++ could be a good start, or knowledge of that is good. JavaScript knowledge is good for Ethereum, Bitcoin Cash, Ripple, IoT, and so on. Similarly, Java is good for some others, Python, Go, Solidity, and Kotlin. Kotlin is another language just like Go and Solidity. So there are 3 important blockchain languages, I would say here. See, one is Go, Solidity, and Kotlin. These are the three languages which are blockchain specific. Python is more of AI and machine learning kind of language, and these other languages existed earlier also. And Go, Solidity are more or less based on JavaScript. So you need to understand JavaScript also reasonably well if you want to learn these two other new languages. And these languages are used for smart contract coding. So that's the advantage of these languages. We saw the 4-layer protocol yesterday, that it starts at the lowest level with the blockchain technology or the actual blockchain. The second layer is the ledger that you built on that blockchain. The third layer we saw was digital assets that you can build on the ledger, and on the digital assets you can build applications. So similarly, you can see here there's another way of looking at the blockchain technology stack. You start with the infrastructure first, in terms of how the chain will be stored, then what will be the network, how will be the nodes be arranged, and what virtualization will you do, and what nodes and what cloud computing resources will you use. That's the infrastructure level. Then you come to the network and protocol level. So we talked of 4 or 5 protocols yesterday, including the network protocol, consensus protocol, ledger protocol, transaction protocol, and so on. We will find them here. There is something called as side chains that we have not covered, but we will cover them maybe when we talk of this hyperledger. So that's also an interesting and important concept to understand what is side chains. Some blockchains support it, some don't support it. It is not forking, that is for sure. So that's something different. Then on top of that layer, we come to the services layer. Here is where most of the application programs and coding and all that expertise is required. So if you want to become a blockchain coder or a programmer or something, then always look at the services layer. That's the one you will use most. The network and protocol and all this layer, even yesterday we saw as per the roles, it is more of a DBA or an admin role. Infrastructure is more at a hardware level. So it is more of computer infrastructure that you need. Then the DBA layer is something like the network and protocol layer. The programmer layer is the service and application layer. And then on top of that, you build business applications, which is the top layer where you decide the UI and business logic and the business workflow and so on and so forth. So that's the typical way all business commercial application products are designed. Now coming to Hyperledger. Hyperledger is not one product, but it's a combination of a lot of stuff from the Linux Foundation. It was started in 2016, I believe, when they assigned a CEO for Hyperledger. And since then, it has been growing. In 2018, it became quite a formal sort of product or a platform. And Hyperledger consists of 5-6 frameworks and 3 tools. So all these frameworks are basically used for programming, and the tools help you to use those programming tools. So I would say that you need some combination of these tools to be used. So typically, the Hyperledger community is an open source community, and on GitHub, you will find all the information about each of these tools. Today, if you look at it, you have to look at all the tools that are version 1.0 onwards. So all the programs or tools or frameworks, whatever are available, which are less than 1.0 version, they are trial basis. So they are not guaranteed to work in production. So if you are going to study them, that's fine, but you don't try to implement them for any live application. So for all live applications, you must look at a tool that is at least 1.0 onwards. So today, the most common tools which are used are Fabric, which is the coding tool for Hyperledger. Indy is a tool that is used for identity management on Hyperledger. So there are some experts. I incidentally happen to know one of my architects from IBM, Alan Dickman, who was a utility architect, and I worked a lot with him. And recently on LinkedIn, I found that he is an active member in development of Indy as a part of the IBM team. So sometimes I connect with him to find out what's best happening on Indy, and he gives me the latest updates. But yes, you can always go to GitHub repository to see the updates on all of them. Similarly, you have Iroha, which is not so popular yet. Then you have Sawtooth, which is almost similar to Fabric, but it has some differences. So certain business applications prefer Sawtooth and some prefer Fabric, I would say today. And then Burrows is another one which is not so popular yet. Then among the tools, Composer is a tool which people like to use who are business analysts. And we'll see one more slide on Composer, how it works. Explorer tool almost everybody uses because it's like the UI interface. So if you are developing something in Hyperledger, then you need the UI, the environment, the development environment or IDE, whatever you want to call it, that's the Explorer. And Cello is another tool that has certain helpful features and it connects with many other things, but that's also not so much popular. So most of the applications today, they directly run on Fabric or Sawtooth, or they use Composer to define something and create some code, and then you go and edit the Fabric code. So Composer can create a Fabric code or Sawtooth code, and then you can edit it. It's same like Oracle Designer, if you have heard or seen that earlier. Oracle product has a designer tool called Oracle Designer, and that generates a lot of code for Oracle applications. Some people like it that way. Some people like to write code directly. So if you want to write code directly without these kind of tools which create halfway code, then go for Fabric or Sawtooth directly instead of going for Composer. Otherwise, this is how the Composer architecture is there. That you write a business application, then use the UI of your Hyperledger Composer to define a lot of stuff, for which you don't need to understand programming so much in depth, but then it generates the Hyperledger Fabric code, and then you have to go and edit that code to make it fully functional. Because even today, the way Composer works is it doesn't create 100% of the code that you need. Some things or most of the things it creates, like 80% code gets created, and then 20% you have to patch in that. So some people like that idea, some people don't like that idea. Okay, so now let us move on to the various components of this blockchain solution that we are talking of, typically Hyperledger. So in case of Hyperledger, you will have all these entities that you need to know. One is the ledger itself, that how the ledger is stored. So we'll see some details of that. You need to write smart contracts in this. So we will see that also, that how do you write business logic in it. In Hyperledger terminology, this is known as chain code. So if you want to search on something in Hyperledger, you need to say how to write chain code. And that is what is exactly the smart contract version of Ethereum in Hyperledger. So Ethereum calls it smart contract code and Hyperledger calls it chain code. Then you have a peer network. So you need to define that how is your network going to be? Is it a public network or is it a private network? And then which are the roles of the individual network people? So then you have a membership services. We saw yesterday that if you have a private network, you need an MSA, that is the membership services authentication or authorizer. This tool or utility or ownership by a person basically implies that there are certain people who are authorized to be a part of this blockchain, and all the people in the world are not part of this blockchain. So that is the use of membership service provider, and that is a built-in tool in Hyperledger. So you can always have a private blockchain created in Hyperledger with a set of members defined by this MSA. So you need to have somebody who owns the MSA, and then that is the person or group who can decide who all can come in this blockchain that you have created. Others cannot come. Then you have events. Events are typically something that are happening between the blockchain and your other commercial applications. So it's a way of communicating with the commercial application, and we'll see more into details. So something that happens in your regular application creates a trigger for blockchain to update something. And sometimes the blockchain creates a trigger for something for your commercial applications to run. So that is quite important to integrate and interface your commercial applications. So all programmers need to know how to manage events for a for a blockchain, Hyperledger one. Then you have systems management, typically to provide, change, and monitor the blockchain components. So system management basically is able to manage all these other components. So it's like an admin role. Then you need a wallet. This is some interesting concept that we have not covered till now, but hopefully you should be able to hear about it or know it, that yes, there are digital wallets, because we said that everything on blockchain works with cryptography, and cryptography requires you to have two keys at least. One is a public key and one is a private key. So your wallet is the place where you store your key correctly. Similarly, all other credentials like your membership or your role authentication or whatever you are allowed to do in that network or not allowed to do, typically what we call as a certifying agency. I don't see that in this list here, but it is there. So you have one more component called CA, or a certifying agency. So certifying agency basically says that if you are a member of this blockchain because of your MSA or because of the membership given to you, what all things can you do in this blockchain? And we'll see what all things an individual node can do or not do. You represent yourself in the blockchain as a node all the time. So basically this peer network consists of a lot of nodes. It's not a username and password, but it is a node. So your IP address and the computer you work on is called a node. So that's how it works. Okay. And so you need a certifying agency also, or a CA. And the wallet is the place where you store all your security keys and your permissions and authentication and everything that you need for the functioning of the blockchain. So sometimes the certification authority might ask you that try to identify yourself, who you are, just like you do a username, login and password. So in this case, you don't have username, login and password, but you need those keys. And the certifying agency will first ask you, oh, you want to create a block? Let me know whether you are certified to do it or not. So you have to show that key and say, yes, I'm certified. So the certifying agency will approve that, yes, you are allowed to create a block. Otherwise, you'll not. So that's how it works. And lastly, you need system integration to integrate with other applications through events. So system integration and events work closely to each other. So any questions, doubts in this before we go ahead? Are you clear on so many components? Now, all these components are built in when you go for a application platform like Hyperledger. If you start a project on your own, then everything has to be done.
Does certificate has any valid time validity certain constraints?
Could be. That's the way you implement the blockchain. So you can say that your certification is valid only till this date. Usually no, but you can. Just like your password expires on some time, or your even membership can expire on some time. So you could have all those combinations, yes. But default is permanent.
Yeah.
By default, once you are a member, you are a member, and once you have some authority through certification agent, you have that authority continuously till it is revoked or somebody overrides it or does something with it. So usually there's not a time-based implementation, but there's a revoking possibility that others can decide to chuck you out. आपको ये नहीं देने का authority. So that again happens by some consensus mechanisms, whether your authority is to be revoked or not. Or sometimes it's a centralized control also, because with Hyperledger kind of blockchains, it's not always consensus. It might be that the CA has the authority to do that, to check out somebody or keep somebody. So they might just inform that you are not a member now, or you don't have this authority now. So there is some control in case of these commercial blockchains. It's not completely public like Bitcoin. No. Okay. Any other doubts?
Yeah, I have a question, sir. You said the CA might ask you. CA might ask you a question on security key. So that means you have to enter or show him. That means you are not supposed to show the actual contents of it, isn't it?
No. You don't have to share your key with anybody, but there is something that authenticates or that ensures that you have the private key, for example. For example, if there's an encrypted message and there is a clear message also, both are available. And then I say that, are you the person who created this encryption? You say yes. Then I say, again, try to show me how you do it. So I send you another message and maybe you can create the same. So it's a way to validate that you are the owner, not to share the key.
Like somewhere IIRS in banking. International banking, you have that IVRS where they put you on that machine and then you enter your code numbers there.
Yeah, could be. Because see, finally, even if you share the key, it is like a machine application which doesn't capture your key. Because ideally, the whole application never has your private key. Only the public keys are stored with the certifying agency. So they know who you are. So using your public key, if they give you something to encrypt or decrypt or something, then they know whether you have the private key or don't have it. That's how they work on it. For example, if you have a private key and I have your public key, okay. Now I want to know that you are not impersonated by somebody else, because somebody else might say, I'm Mr. Irve and here, can you allow me to do this? I can do a simple thing. I'll send you a document. I'll say, please encode this and encrypt this, send it to me. So you encrypt it with your private key, send it to me. If I can decode it with your public key, that means you have encoded it. Nobody else encoded it. Because third party cannot encode it with your private key, right? That's a simple way to check. So I don't need your private key, but I can send you a document and say, please encode this and send back, or encrypt this and send back.
Okay, understand, sir.
I will look at your public key and try to decode it and check the two documents. If they are the same, that means you are the owner, or you have that private key corresponding to this public key. And the CA always stores all the public keys of the participant, so they know who they are. That's how they identify. Getting it? Okay.
Sir, right. There is one question on the chat box.
Okay. One example for smart contract. Yeah, we'll come to that. Please hold on. Smart contract examples will come to. So let us come to some of these components in the Hyperledger blockchain. So as we said earlier, a blockchain gets created by Hyperledger automatically. So you don't have to create blocks, you don't have to do mining, you don't have to do anything of that sort. It already creates something known as a hash chain. Now in Hyperledger, it keeps two components of the blockchain, not one. The component you see on top here, this block is the actual blockchain that we saw. It has transactions built into blocks, and all these blocks are chained together. Now you find something else which is here called a void state. We'll come to that. So first of all, let us say that this blockchain is here, and all these blockchain is created by Hyperledger automatically once you give it an input that I want to make a block out of this. This is a valid block. Somebody validates it saying that, yes, I want to create this block. It just goes in, and we'll see that step also, that how it goes in and how it creates. But the Hyperledger as a product will create the blockchain for you and maintain it. You don't have to do anything beyond it. It's just like you use a database using SQL commands. You say, please insert a field in this table, and it goes. You don't know how it got inserted, where it went, etc. You don't have to do Merkle trees, and you don't have to do hashing and pointers and nonce and all that. You don't have to do. Hyperledger does it for you. Now what happens is, we said earlier that if you want to validate something that's happening as a transaction, then you need to go back in the chain and keep tracing the origin, that if somebody pays money to somebody, for example, that did he have that money in the first place? So you go back and keep tracing that. Now in business applications, it doesn't make so much sense to keep going back and forth and tracing, because the time required for that becomes more and more. So what we do here in Hyperledger is they create something what is known as a void state, or that is the latest closing balance, I would say, for anybody. So if you create a ledger, for example, then there's a running closing balance depending on the transactions that you have. So you have an opening balance to start with, which is 0. Whenever you become a member and start transacting, your balance starts coming. So you always start with a 0 balance, and then you get some money and so on. So what is your current balance or closing balance is what is known as the void state. So void state is essentially a duplication of something that you can arrive at from the blockchain, but this is stored separately. And there are certain advantages of doing it, and Hyperledger stores it in a traditional database as a key value store. So this key value pair, that is, this is the key or the ID, and this is the balance for that. Now this can be verified on the blockchain if you doubt it, but otherwise, if you don't doubt it, you can start using that value and don't need to go and traverse in the blockchain all the time. That's the whole idea of doing it. And they allow this duplication of information and ensure that it doesn't get corrupted or it doesn't get disturbed from the original blockchain, because both of them get updated at the same time through events. So that's how they manage it. So there are a lot of advantages of doing it, but it is not the ideal state of world, because there are two things now. Okay, coming next, we will see how to integrate with existing systems. So the box that you see there is the Hyperledger box on the left side. Now there are some other applications that you're running, because your full application is not blockchain, for example, but you are running a business application which requires certain blockchain contents. So the way it starts it, you start with a systems event. So your existing application will send a trigger an event saying that this something has to be done in the blockchain. Or alternately, the blockchain could trigger certain events and say that your system should take care of these events. So both ways the event could start. Now, once an event is triggered, that means some action is to be taken in the other end. That the blockchain says that the system should take action, or the system says blockchain should take action. So there is a call into the blockchain network from existing systems. And then both these systems connect and do something. Typically, that has a transformational effect, and then the blockchain gets updated. So whether the blockchain should be updated or the existing system should be updated, that is decided by type of event and what is to be done. And then both of them get into synchronization. So the call is again go back to the system. So this is a two-way exchange of events, and these two work separately as compartments today. So it's not like you build a blockchain application and there's no other application, but you build a regular application, let's say a web-based application with database, and then it updates something in the blockchain. Okay. So there could be some triggers from blockchain to update your application, and there could be some triggers from application to blockchain your your blockchain. We will see what happens in the blockchain with these triggers now, because the basic application, I think you know that you can have a web-based application, and based on user inputs, you can update databases, you can view, delete, you can do all that in databases, and then you can have some new state of the system depending on whatever was the transaction. Now coming to this block of the blockchain part, there are many elements here, so we need to know. Firstly, Hyperledger has this thing called membership services. So membership services is the first point where you come to know whether you are a member or not, and this is managed by a group called admin. So there is an admin and there is a control in the Hyperledger blockchain. Now people who are promoting public blockchains, they don't like this idea. They say this admin can be corrupt, and then there's a problem. So they don't like that idea of admin, but that's how it works. Hyperledger says yes, admin is required and admin has certain authorities to work. So admin is required to create membership services. The second thing you require is this Fabric CA, which is shown here. Fabric is one of the components. So you could have Fabric CA, or you could have a Sawtooth CA, or you could have some other CA. That is the certifying agency. That what is the role allowed for you as a peer node. So Fabric CA will have the list of nodes who are participating in this through the membership service, and then what are roles and responsibilities they have. You might have an external CA. So there are two things available here. One is a default CA that Hyperledger provides as a certifying agency, but you can have an external certifying agency plugged into it optionally. So you can say, I don't trust Hyperledger's Fabric CA, it might be corrupt, or I don't like the features in that, and I have developed a separate certifying agency, a third-party agency, and it can be integrated into it. So that's not a problem. The advantages of having external certification agency is that all the public keys and the member information is stored here. So if you want it not in Hyperledger but in your own private database or somewhere else, you could do that. Then we see the applications part here. So you have these business applications. They have a interface. They use a software development kit, and they have this interface to work with the blockchain, the events that we saw. So these events come to the blockchain, whatever those transactions you create. And we will see how that smart code and all that works with all these kind of events. So smart code is a part of the blockchain itself. So all the code that runs in the blockchain is smart code, and all the code that runs in the application is your normal application code. Now what happens in this blockchain is, let us say you want to create a transaction or something. So let us say you want to have a car registration that you want to change from A to B. That's a requirement in your application, that somebody sold a car. Now you want to change its registration owner from A to B. And let us say A and B are both members of this blockchain, or they are not members, but the application says that here are names A and B, please change it. So it comes here as a request. So there are three things required to be done here in this peer network. One is an endorsing that you see here or here. So endorsing is the first step, ordering is the next step, and validation is the third step. So these are the three steps to be done. So what happens is, when this request comes, let us say the blockchain checks that who is requesting this. So obviously, if you look at the logic, then ideally the way I would code it is that there is a seller and there's a buyer. These are the two parties involved in this transaction. So can I ask the seller to confirm that I am selling this car to XYZ? Similarly, can I ask the buyer to confirm that I am buying this car from XYZ? If both of them agree to the same thing, because we are keeping only one record here now, we are not going to seller's system, not to the buyer's system. Although they may be companies, they may have their own applications, etc., etc. We are looking at a single record here, or a single transaction across those two systems. So the endorsers in this system will be two people, that the seller and the buyer. If both of them agree, first of all, that yes, I have sold and I have bought, or I am selling, I am buying, then they use their keys and endorse the transaction. So the transaction gets a endorsement, that seller endorses, buyer endorses, some XYZ key is there, or their digital signature is there. Then it goes to the next step. It goes to ordering. That's the next step. Ordering service is here. So some nodes in this network have this authority of ordering. Some nodes are endorser nodes. So now this can be dynamically decided also, that who is the endorser. For example, that is what the authority can do here, and find out that given a transaction which is involved between, let us say, parties A and B, then endorser are party A and B. But if the transaction is between party C and D, then it will say that endorser should be C and D, not A and B. And these are called as channels within the Hyperledger product. So they create channels where different parties can talk to each other. And typically these parties are not individuals, but they are business entities, because we saw yesterday also that each business entity has their own network or their applications, and they want to create a single application where all these business entities agree on certain transactions across them. So we will ensure that, let us say there is a car buying and selling agency, for example, and there's another car buying and selling agency, and then a buyer comes to one agency to buy a car and a person comes to other agency to sell a car, and these two agencies want to talk to each other. Then they can use blockchain because they have their own applications and they can confirm. You cannot think of random individuals trying to use blockchain for this unless all of them become members, etc., because the blockchain cannot validate that who are the random people who are coming to ask whether they want to buy or sell. But you can definitely think of it as two car selling agencies or car selling and buying agencies who can interact this way. And they confirm that, yes, I have a customer who is buying this car, and somebody else says, yes, I have a customer who is selling this car. So then they are registered members on this. Otherwise, you need all registered members. So random people cannot be registered here unless you create a public blockchain then. And public blockchain becomes more complicated if you want to do that. So endorsing is first step. After the transactions are endorsed, they go to the ordering service. So until both these parties endorse, the transaction is hanging. It doesn't complete. And if it is complete, then it goes to ordering service. So ordering service basically looks at all the transactions which are complete, keeps compiling them across different channels, different parties, because it has nothing to do with the transaction. It just looks at how many are there. It gets all those transactions and creates a block. If a block is possible to be created, it will create a block, otherwise it will wait. And it will do some basic validation that the transaction has an endorser, somebody has endorsed it, it is correct, etc., etc. Nobody has rejected it, and so on. So ordering service sends the ordered transactions or a set of documents to committers. Committers are another set of nodes. They can be endorsing node, they can be third-party node, they can be anybody else. You can decide how these committers work. So committers, what their job is to look at all the transactions in the ordering service created block and confirm that all these transactions are correct and they can be committed. So what they check is, they check that the endorsers are correct, their private key or whatever the public keys are there, they can use their public key to check that this person has endorsed this, somebody has, so they do this kind of checking. And they also run sometimes the chain code that you see there. So they might run chain code also to validate all this. Some endorsers also might run a chain code, because an endorser party also might need to know a lot of details about a transaction, and they have their own business logic to confirm whether this is a correct one or not. If somebody said, for example, if somebody says that I am buying a car from your agency, so he doesn't know why you are buying from my agency, because he has to look into his own application to see that which car I am selling and is this confirming or matching with that. So either you could do it manually or doing through chain code. So chain code can be used, and then this gets committed. So this validation part is done by the committers. So first of all, you have endorsers who propose a transaction saying that we believe that this transaction is valid and we want to do this transaction. It goes to the ordering service, which puts all the transactions in a sequence, and then it goes to the committers to validate that all these block, because there could be relative transactions. As I explained yesterday, if you have 10,000 rupees and you give 5,000 to somebody and 8,000 to somebody, then individually those transactions look correct, but together they are not correct. So those kind of checks can be done by the committer only. The endorser cannot do those kind of checks. The endorser might say, because let's say I am an individual, I'll say, yeah, I agree. I paid 5,000 to this fellow, I paid 8,000 to that fellow, and I'm happy about it. But the committer will say, no, this is not valid because you are supposed to have 10 and you cannot pay 5 and 8. So some transaction will be rejected out of that. That's how it works. And then further, once this process is over, the block gets created. And if there is an event to be triggered to the basic application saying that all these transactions got committed, etc., all that is forwarded to the application back. And chain codes are used by endorser, committer, or ordering services to run those validations or whatever they want to do. I hope this makes it reasonably okay for you what the Fabric does on its own or what Hyperledger does on its own. So the advantages of doing that is it better reflects business processes by specifying who endorses these transactions, etc. It eliminates non-deterministic transactions. So all transactions which are getting rejected by the endorser or by the committer, they are either kept hanging because they are not okay or they are rejected. So there is a separate database they create or a separate place where they keep all such hanging transactions, and the owner is notified back. So the business application that create that transaction will get back a notification saying that your this transaction has not been accepted in the blockchain, so it will not be recorded. Now you better change it or suggest another one or resubmit it or do something. Okay, the scale and the number of participants and the transaction throughput becomes a concern here, but that is also being addressed by all this. Typically, the way Hyperledger addresses it is by creating multiple channels, multiple nodes, and the authority given to multiple nodes. So, for example, you say that endorsing nodes can have redundancy. That means that any two of these 5 persons can endorse. Then even if some people are not active, then you can have at least somebody else endorsing it. And those are the kind of rules that you define in the Hyperledger setup. That how many people are required to endorse a transaction, who are those people, are there X out of Y people who can endorse it, or only one can do it, or and then all this, even for a committer, that how many. So committer will basically look at all the rules and say that is this transaction as per the rules. So first you define a set of rules, act on that, and the endorser does it, committer validates, and then rejects all the transactions which are invalid. So to summarize, I would say that these are all the components in the Hyperledger architecture. You have membership, you have the blockchain itself and the transactions, and you have the chain code, that is the smart contracts that you write, that is called chain code here. So within membership service, you have registration of members who become members of your blockchain. Then you need to have identity management, that if they want to log in or they want to do something, then you need to know what is it that they are doing. And then you have the auditability. So all the transactions that a member does should be auditable. That is the best part of blockchain, so that provenance is always there. So you can go back and trace that who did what. So auditability for each member's activities is always there on the blockchain, and you cannot say I did not do something or something vanishes or nothing like that happens in it, because once committed it remains there. Only the transactions that are not committed or rejected, that may or may not have the auditability, because that's up to you to find out whether the rejected transactions also need to be kept somewhere in separate chain or separate place and audit, or leave them. Okay, then coming to the blockchain services part of it, you need a consensus manager, you need the P2P protocol, that is all these nodes, whether they are endorser or ordering nodes or committing nodes, they need to know how to talk to each other. And then what message goes from whom to whom, that is the P2P protocol. So all these nodes, which are maybe hundreds of them, you need to know every time that which node is trying to connect to which node. For example, if there are 2 endorsers required, then some message should go to both those endorsers that now you are supposed to endorse something document which has come. And if one of them endorses and then the second one has to endorse, then it has to follow that workflow. So all that is done by the P2P protocol service. Then the distributed ledger basically stores it. And the ledger storage is again that whether you do the side chains or you do the main chain or you use the world view, so all that is managed there. And lastly, you have the chain code where you write secure. So container services are used for that, and there's a secure registry used for creating the chain code also. So it knows who created the chain code and whether all other accepted it. And if a chain code is to be run, then everybody runs the same code. So that's the advantage. Just a minute. Somebody trying to call me. Okay, sorry. Let's go ahead. Now let us briefly look at some other tools which are available. For example, Ethereum is another product. So at present, this is the news I heard yesterday. So something keeps happening in that. So Ethereum's architecture was a proof of work till now. And with this upgraded version called Ethereum 2.0, which people have been waiting for a long time, it is planning to switch over to proof of stake consensus mechanism, because it realized that proof of work like Bitcoin requires a lot of energy and power. So they're switching to POS, which requires little less energy consumption. And Ethereum's latest upgrade has taken it one step closer to what is scheduled on 4th August release. So it was released on 4th August. And this is supposed to be a long-term solution that will bring back the stability to the Ethereum network. So this Ethereum 2 will not only improve speeds of transactions, but improve upon scalability and programmability of the blockchain itself, with no compromise on security. Typically, Ethereum transactions were happening today at something that is before this version 2, they are happening at around 15,000 transactions per second. Now they are expecting that 15 to go to thousands of transactions per second. So that's the jump they are expecting. So that's one news on Ethereum. And if that happens, then Ethereum will be very powerful platform. It's I would say it's a contender to Hyperledger platform. But the basic difference between Ethereum architecture and Hyperledger architecture is that Hyperledger does not require any cryptocurrency for you to work with. So if you are hypersensitive about using cryptocurrencies and you're worried about the legal aspects of it, that like many people are, then you can't use Ethereum, because Ethereum has to use Ether as a gas and you have to pay in Ether. So now you have to get Ethereum as a currency to run any public Ethereum network. You can run only private networks, and that too like a pilot network or something with few users without actual Ethereum, and you can create your own Ethereum tokens to run that kind of network. But it cannot run on the internet and so on. So you have to have the real Ether or Ethereum currency, which is the cryptocurrency that you need to purchase and use for running Ethereum applications. For Hyperledger, that is not the case. But if you want to run Hyperledger again, there is a sandbox application available from IBM, which is free. And you can do some minimum things on that, like creating nodes and creating endorsers, committers, etc. But it has no commercial value, because the number of nodes that it supports are very few. And if you want to go beyond that, you have to buy the license from IBM, paying something like, I think, $1,500 per year or something as a fee for the minimum configuration. And then you can upgrade that configuration to higher levels if you want. So you have to start paying fees to IBM for using their platform. So it is a different model. Ethereum is a different model. Ethereum uses its currency called Ether, and if you burn Ether, so to say, or you put Ether into that engine, then it runs. So your smart contracts run on Ether. And depending on the time it takes for the computers to run it, the Ether is charged to you. So the charging is also based on what applications you run and what smart contracts you want to run, how much resources they need, and so on. Unlike Hyperledger. So there are two different kind of products. Okay, now this we will skip. If you are interested in building decentralized applications, or dApps as they are called in short, you can look at Ethereum as one of the platforms. And a lot of people are using the Ethereum also for building. We have not covered Ethereum today. We covered the Hyperledger product. So now let us quickly look at one or two things. One is what are the steps that you follow for starting a blockchain project compared to some other project. I think you're already doing a DevOps part of it. So that's a parallel track we are doing. But as far as application development goes, you will find that all these steps are required in a general application as well. The one in red are the differences in blockchain project. So all that in black is similar to the existing project. For example, you have to analyze requirements, which is same. You have to translate participants into nodes on the blockchain network. That is something you have to do. In a normal application, you will have a username and they will have a password. And that is how you decide who is the person logging in. But here you go by the node name. And then all those are nodes in the blockchain. So you need to define the nodes. You need to define the role of the node also. That this node, can it be an endorser? Can it be an ordering service? Can it be validating node? And so on, like a committer node or not, and so on. Then you decide the blockchain platform to be used for programming and the programming language. For example, will you use Hyperledger or will you use Ether network? Similarly, will you use Go or Solidity or what other language, and so on, or Kotlin? So you could use different languages for that. Then you decide on a consensus model to use. That is what workflows are allowed and what is your business logic for coming to a consensus saying that this transaction is correct or not. Who all need to say yes or no to it. Then you decide an incentive scheme for node participation. Now this is again optional. For Hyperledger, you might say there's no incentive scheme and still the nodes will participate. But then you have to find out how they will be motivated to participate externally outside the blockchain. But otherwise, you need to have an incentive scheme, because all these companies who work together on a blockchain, they are not in the same company. They are like different companies who want to talk to each other. So obviously, everybody will be interested in the financial part of it also, that what gain do I have if I become an endorser? What is the gain I have if I become an ordering service? Because I have to do this social work of ordering all the transactions across all people who are the members of the blockchain. I cannot say that I will endorse only my transactions. I will only order my transactions and I will validate only my transaction. No, you cannot do that. then it is not a blockchain. That is the whole idea of blockchain, that you publicly validate and endorse, and so that incorrect things don't happen in the blockchain in the first place. Then the rest of the steps are same. You need to identify resources, you need to identify development method, hosting, support, all that. And that goes more into DevOps, the deployment part of it, which we are anyway covering in the other stream. Lastly, I would like to touch upon a few challenges with this blockchain technology, not just Hyperledger, but why this technology is not picked up so fast, so soon. With Ethereum 2.0, I don't know how much of this will be helped, because scalability is one such issue. Scalability is basically how many transactions you can run in that blockchain and how secure they can run. So if you have larger blocks, that means slower propagation on the network, while smaller blocks makes it more complicated and time consuming. So there's a trade-off between making larger block size versus smaller block size for scalability and the algorithm that you use. So whether you use pure proof of work or proof of stake. For example, Ethereum has already decided to move to proof of stake, but Bitcoin has not done anything of that sort. They are not too worried about it. Currently, Bitcoin does only something like 7 transactions per second, compared to a credit card which does 15 to 20,000 transactions per second. So that's the big difference between Bitcoin and credit cards today. The second challenge is selfish mining. Because of mining activity, there are a lot of miners who form pools and they form company of miners, and then they monopolize this activity of mining. So that's another problem which is being faced by the proof of work. And proof of stake has some better advantages over the proof of work as far as this mining pooling goes and problem. The third one is privacy leakage. There is no guarantee that transactions will be private, although originally Bitcoin started with that, saying that you will not be able to trace the user. So that is a big question mark all the time. There are certain blockchain applications or even currencies which are created to be completely private, and there is a big problem of identifying individuals in that. But then there are some others who say that we don't mind even if individual identities are known, because for business transactions, we are not too worried about secrecy of the business entity who is into this transaction. So there are two streams on thought on that. So some people agree on anonymity and simply nobody knowing what is happening there and so on. So there are different methods people are trying to crack on that, and there are different tools coming up which say that we will make it more anonymous and you can't crack it. So there are some currencies which work on that, and typically all the black marketing people and the terrorists in the world, they use those kind of currencies. I will not get into those names, but there are 2-3 famous or other infamous cryptocurrencies which are used for that kind of applications, and it's almost difficult or impossible to trace how that currency is floating. But since there are very few such terrorists and those people who use it, so it's not so popular, and then finding them and identifying who is transferring to whom is also difficult. So I won't have much data on that to figure out what's happening. But yes, there are certain coins which are well known in this crypto world that they are used for all kind of gambling purposes only. Okay, then the consensus method is another one as a challenge, that which one you use. There are certain methods which have waste too much electricity, then something favors richer people like the proof of stake. And then that BFT are not suitable for public blockchains because they require the node identity, so that anonymity is not there. So there are different trade-offs again for consensus mechanisms. And lastly, you need a governance model for blockchain. So there are several issues on this governance. So if you want a public blockchain, then it doesn't require a governance, but all these private blockchains require some governance about membership services, about CA, that is your certifying agency, and so on and so forth. So now how these people should not be corrupt and all will be the next level of questions that will be asked. So yeah, there are no easy answers to it today, but people are trying to work across all this. That is it better than the existing system? I would put it only that way. Okay, so with that, we come to the end of the session today. I think we will have Ishan already joined. Has Ishan joined? Hello, Ishan.
Yes, hello, I'm here. Hello.
Oh, yeah, just give me another minute and I'll close. Okay, so with that, I would like to thank all of you for attending this session right now. And we have Ishan from Seneca College, who will be talking to you about blockchain applications for fintech and some opportunities in Canada. So maybe we could take this questions at the end, or if you have one or two quick questions, I could answer them right now.
Can I ask one quick question, Atulji?
Yeah, sure.
College campus cash, can it be a hyperledger? So it becomes perfectly legal thing instead of going for Ethereum.
I would not recommend that way, because if you go for these commercial products, first of all, you need to pay a lot. And secondly, you'll not understand the basic concepts behind it. It's like using an Oracle database for something. Instead of that, today, since blockchains are not so well established, you better use something that is open and you can manipulate it a bit and learn the basics of it. And it's like going to the nut bolts of it. So instead of using high level languages, like you learn Unix and you learn C programming, that's how I would put it. So that's always better to start that way rather than high level languages.
Thank you, sir.
Okay. Anyone else? Okay then. Tigray sir, would you like to introduce Ishan? I'm done with my presentation.
I'm waiting for his joining, sir.
He has joined. Ishan, you're there, right? Yeah, he's there.
I'm here.
Yeah, Tigray sir, he's there.
Okay, Ishan sir is here. Sir, welcome on behalf of SVERI family.
Thank you for having me. It's a pleasure to be here.
Same here, sir. Over to you, sir, please.
Okay, so good morning, everyone. Sorry, rather, I should say good evening, everyone, since you're all in India and I'm here in Canada. It's very early in the morning. It's 8:35 here. I suppose it's rather late in the evening over there. So good evening, everyone, and
6
thank you
o'clock.
for joining us today. It is 6 o'clock, right?
Yeah.
Oh, so I expect you're all running out of energy by now. So I'm going to try to keep this presentation as simple and low-key as possible, all right? So first of all, about myself, my name is Professor Ishan Srivastav. I'm faculty at the School of Accounting and Financial Services here at Seneca College in Toronto, Canada. Today, we'll talk a little about fintech and how blockchain plays a role within it. So I understand a lot of you come from a technological background, so we're going to access this entire presentation more from a financial perspective to try and see exactly what use cases we can have for blockchain within fintech. So let's start first by defining fintech. Now, fintech as a word is an amalgamation of two words, finance and technology. I mean, that much is pretty straightforward. But then it's not really a new concept. See, the concept of fintech is simply all technologies that are used to conduct financial transactions. Now, this is ranging all the way from the use of coins in prehistoric civilizations, all the way to the invention of paper money in China, from the use of double entry ledgers in Renaissance Venice to the Bretton Woods system post-World War II. All of this qualifies as fintech. So fintech is not necessarily a new field. It's a very old field. But the buzzword that we use nowadays relates more towards digital financial technologies as opposed to analog financial technologies. So that's really what we're focusing on here. So before we can understand exactly what fintech is, we need to understand the financial system itself. Now, the crux of a financial system is what happens within it, which is trading. And when we have to define a financial system, we need to try to find the actors within. We need to define what is traded, we need to find who is involved in the trade, and we need to define where the trading happens. So let's start with the what. The what are called financial instruments. Anything that is traded is called a financial instrument. Within the purview of that particular financial system, it becomes a financial instrument. So you can have any entity that qualifies to be a financial instrument so long as it fulfills three different roles. The very first role that it must fulfill is what's called a store of value, which means you, the owner or the creator of that particular entity, that particular object, must see value in it. That is the first role that must fulfill. After all, I mean, if you don't see any value in the item that you hold, you're not necessarily going to be trading it, are you now? So the first thing, the crux, the most important aspect of a financial instrument is that it must be a store of value to the owner, to the creator. The second thing is that it must not just be a store of value to you, but also to other people, which means other people must be willing to see value in it as well, not just you. And based on that value, it becomes a medium of exchange, which means people are willing to accept that item in lieu of payment. Say, for example, somebody comes and mows my lawn, and I need to give them $20. Now, I don't have $20, so I say, okay, how about I give you a steak dinner instead? Now, most likely because they're exhausted and there's no other retinue, so they'll say, okay, sure. So for that particular financial transaction, which was the mowing of my lawn, the service provided was the mowing of the lawn, and their payment, instead of it being cash, now it's being that steak dinner, because I saw some value in that steak dinner. The guy who mowed my lawn saw some value in that steak dinner, and we agreed to accept that as the primary currency, as opposed to any other thing like cash. So that is the second rule that it must fulfill. It must be a medium of exchange. First rule is that it must be a store of value, which means you, the owner, the creator, see value in it. The second rule is that it must be a medium of exchange, which means other people see value in it as well and are willing to exchange it in lieu of payment. The third rule that it must be is that it must be a unit of account. What do we mean by unit of account? Simply that you measure your wealth in terms of that item. You measure your wealth in terms of that item. Now, most people across the world measure our wealth in terms of the currency of the country that we live in. I, for example, measure my wealth in terms of Canadian dollars. You, for example, might measure it in Indian rupees. Some persons might use euros, some may use dollars. There's a whole bunch of currencies out there. But then currencies are not the sole financial instruments in the world. There are people in the world who measure their wealth not by any amount of cash, but rather by how much land they own. Some people measure their wealth in terms of how much livestock they own, how many cows, how many sheep, how many goats. And they use these as their financial instruments for that particular financial system. So remember, a financial instrument is not necessarily just cash. Cash is just cash, and money is just the most common type of financial instrument out there. But there can be many, many others. Bonds, shares, all of these are financial instruments. You can use them for trading. The only thing that differentiates cash as opposed to money is that it is the most common one. We use it almost every day. Say, for example, you go to the grocery store, you want to buy a bread. You're not going to give them share certificates in return. Most people are willing to accept the currency. So that's what we're going to use. So that qualifies as a financial instrument, the what aspect. Next, let's look at the who. Now, in every financial transaction, there's always two people involved. There's the seller and there's the buyer. These two are always ever present. You cannot have any financial transaction without a seller and a buyer. So when these two are in close proximity to each other, they don't really need anyone else. They can just do the trade with themselves. The buyer can buy the service and pay with the money as necessary. But sometimes there are factors that affect this transaction. Some of these people, say, for example, might be too far away from each other. The distance plays a role. In that case, they would need someone to come in between to facilitate that trade. That entity is called an intermediary. Why do we call them an intermediary? Well, because they come in the middle and connect the buyer and the seller. That's why we call them intermediaries. Examples of intermediaries could be banks, could be postal services, all of these things that facilitate a trade. Not necessarily just getting money from one place to another, but also the product from one place to another. So banks, foreign exchange transfers, all of these would be examples of intermediary institutions. There is one more entity that is involved in financial transactions in the modern day, and these form as the regulatory bodies. Now, a buyer and a seller, individually, they need to come to a consensus as to what they want to sell. But if the seller has a pure monopoly on the item that is being sold, they can charge exorbitant prices on whatever they are selling. To control those prices, you need regulatory bodies. Usually these are governmental bodies, but sometimes they can be non-governmental as well. So regulatory bodies. Four entities within the financial systems. Who are these entities? These institutions. We have the seller, we have the buyer, we have the intermediaries, and we have the regulatory bodies. Four institutions. Next, let's look at the where. The where financial transactions happen is called a market. Now, unlike the others, when it comes to markets, markets are not necessarily a singular type. All of these that you see here can be used to describe a market. So a market is more nebulous than financial institutions or financial instruments. You can define a market based either on the instrument that is being traded in there or the type of institutions that are conducting the trading. For example, if you're talking about the instrument, you can talk about the type of instrument. Are you talking about a long term or a short term? Are you talking about cash? Are you talking about commodities? Are you talking about bonds or shares? Whatever. Each of these will describe that particular market. Another word that we have in here that is rather, that I expect most people would not know, is the term of liquidity. Now, liquidity, and this is something that is very common in finance as opposed to in engineering. In engineering, if you have a term, then that term means the same thing in every context. If I talk about laminar flow, then laminar flow means the same things everywhere. But liquidity, terms like this, for example, can have duplicitous meanings. One meaning of liquidity could simply be about the organization itself, the institutional liquidity, or it could mean the instrumental liquidity. Instrumental liquidity, what are we talking about? Now, when you ask business students what liquidity is, most of them will say how quickly you can turn something into cash. That is an example of instrumental liquidity. But it's not the best way to think about it. The best way to think about instrumental liquidity would be to say how easily, or rather than how easily you can convert something into cash, how quickly must you either convert something into cash or extract value from it, otherwise you risk losing its value. That is instrumental liquidity. How quickly must you either extract value from the entity or turn it into cash, otherwise you risk losing the value. Say, for example, a glass of milk. So you take out a glass of milk at the morning. By the end of the day, either you drink the glass of milk, extract value from it, turn it into cheese, again, extract value from it, or you sell it to someone, turn it into cash. Otherwise, what happens to the glass of milk? It goes bad and you lose the value that was held therein. So that is an example of instrumental liquidity. Another type of liquidity we can have is what's called institutional liquidity. An institution's liquidity simply means how easily they're able to pay their short-term debts using only the short-term assets. A simple way to explain that would be this. Say, for example, if I go and buy some groceries, the bill comes out to $100. I say, okay, I can just take out my wallet and give them $100. Right? I should be able to do that. I shouldn't have to go and sell off my motorcycle to get the cash with which I can pay, which means I'm able to cover my short-term debts, my short-term expenses, using only my short-term assets without having to liquidate my long-term assets. So that's a duplicitous term that you have to consider within the financial field. Another duplicitous term that really comes to mind is the word capital. Now, capital can mean multiple things. In one context, capital can simply mean the liquidity on the item itself, on the instrument. Short-term assets are known as current assets, whereas long-term assets are known as capital assets. Another way you can understand capital is it simply refers to resources. Any resource can be referred to as capital. You can have monetary capital, which is money. You can have intellectual capital, which is your brain power. You can have you can have intelligence, right? You can have a bunch of different types of capital. All of these are just represent different resources that you may have at your disposal. You'll also need to consider the type of the institutions that are trading within. Is it a public or a private market? A public market simply means that it's operated by the government. A private market means it's operated by private institutions. It's the primary or a secondary market, which means is the seller and the buyer going directly, or are there intermediaries involved? If I am selling something directly to you, then that would be an example of primary market. If you take that item and sell it to someone else, that would be a transaction in the secondary market. Right? So you need to consider all of these when you're trying to define what exactly a financial market is. So once we have done with all these three, let's look at what comes into next context is payment systems. Now, payment systems. Now look at this diagram here. Each of these circles represents an individual financial system. Now, when we talk about payment systems, we have two types of payment systems. We have what's called closed loop, and we have open loop. Closed loop payment systems simply mean currencies, financial systems, wherein the currency just revolves within. It cannot go outside. So say, for example, if you go to one particular store, you get some reward points. Those reward points can only be used at that particular store. Can't be used at any other store. Say, for example, if I go to Starbucks and I have some reward points, I can't really take those reward points to any other coffee shop and get them. No, I need to use them only at Starbucks. So that's a closed loop financial system, right? On the other hand, we have what are called open loop financial systems. So let's take an example here. We have financial system A, which has its own currency. In this case, it would be the euro. We have financial system B, which has its own currency, which is the dollar. And we have the financial system C, which has its own currency, which is the rupees. On a micro scale, when you look at it, each of these may be the currency, maybe the financial instrument used within that particular financial system. But then the national currency would work in all of these stores. But when you look at a macro system, you realize that these sovereign currencies like rupees or euros or dollars, they're all closed loop as well. Say, for example, if I come to India, I can't really pay my debts. I can't really pay my bills with euros, right? I need to use rupees for day-to-day transactions. And that's exactly what I need to do in here. When you look at it from a macro scale, you realize that all of this, excuse me, that all of this really is a closed loop system. So what we really need to connect on a global level is a currency that will work at all of these three different financial systems that has the same value across the board. Finding such a currency is what our challenge really is. Now, blockchain and cryptocurrencies offer us something that may get us close to it, but we're not exactly there yet. Next, let's talk about ledgers. I'm sorry, someone's microphone is on. Could I ask everyone to please mute yourselves? Thank you very much. Super. Okay, so ledgers. What's a ledger? A ledger is simply a record of transactions that occur within the financial system or outside it. Now, again, let's look back at the different financial systems. Each of these currencies will work within them, but then if you want to exchange, if you want a transaction to happen from one financial system to another, you'll need to go through an exchange, and that exchange will convert currency A into currency B, which you can use as financial system B. What we're really trying to come up with is currency X, a universal currency that will work in every financial institution, in every financial system in the world. That is really what the prospect of blockchain and cryptocurrencies are. So again, let's come to ledgers. A ledger is simply a record of transactions. The details of every transaction activity are stored in a ledger. Now, ledger transactionally, historically, have been centralized, which means each of these, when you look at these diagram here, each of these small dots is a node, is an entity involved in the transaction. And at the very center is another entity, another node that takes responsibility and records all of these transactions, right? That's called centralization. Centralized platforms, they require all data to go through a central hub, which means you can't send or receive any data without having to go through that central hub. The central hub is a single point of contact that controls all the movement of all data, of all transactions within, right? That's a centralized ledger. Now, a decentralized ledger, on the other hand, is not too dissimilar from centralized. It's only spread out a little more, which means instead of having one reporting node, you have multiple reporting nodes. What we're really aiming for is towards a distributed ledger. What happens in distributed ledger is that you have each node connected to multiple other nodes, right? So each of these nodes is connected to the other nodes, and the records of transactions are shared between them. Now, how does this affect us? How does this really change? Think, for example, say I buy something from you. I buy a loaf of bread from you, and I say, okay, I'm going to give you 100 rupees in return. So you make a note of that in your ledger, I make a note of that in my ledger, and that's it. Now, if I was in a nefarious mood, I could simply just break into your ledger and change that to 1,000. I could say, oh, I accidentally paid you too much. You need to return 900 rupees back to me. In that case, it's just your word against mine. It's a very insecure system, right? What we're trying to do is turn it into a distributed ledger system, which means that if I buy something from you, you make a note of it, I make a note of it, and everyone else in that conference makes a note of it as well. So which means that if I want to now make a change onto that transaction record, not only will I have to break into your ledgers, I'll have to break into all of their ledgers as well. That makes it almost functionally impossible to do. That is what a distributed ledger really is, right? So again, a centralized ledger is simply a centralized platform that requires all data to go through a central hub. Decentralized platforms, on the other hand, do not require that, which means these are known as peer-to-peer networks. You may be familiar with centralized platforms like Facebook and Google. Decentralized platforms, an example of those would be what we used to have back in the day called LimeWire or BitTorrent, which means the data set is not necessarily stored. Say, for example, if you want to download something online, you have to go to that particular database and download it directly from there. But when you look at platforms like BitTorrent, the data set is kept in multiple places, and you download parts of it from multiple places and then assemble it, aggregate it all together, and you're at your end. That is an example of a decentralized platform. So the key advantage of a decentralized platform is that it's much, much harder to conduct frauds with them. Okay. So let's look at blockchain. Now you've already from what I saw, you've already gone into the depths of blockchain from a technological perspective, but we're going to go over it just as a quick refresher. Now, blockchain is a specific type of distributed ledger that forms a chain of blocks. Each of these blocks contains information and data that are linked together and verified through a consensus. So that's a key word, consensus. We'll come to that. Each of these blocks then are validated and strung onto the chain of transactions and then the information in the previous blocks. So each of these blocks contains a certain information about the transaction itself, and you have what's called the hash, which is the transactional data, the verification data that actually hooks onto the previous block, right? Which means if I need to make a change in block 1, I'll have to go through all of these blocks first, which makes it functionally almost impossible to break into it. These blockchains are really designed to record transactions or digital interactions and bring much needed transparency, efficiency, and added security to the financial system therein. Blockchains really address, they solve what's called the Byzantine generals problem. Now, the Byzantine generals problem is an age-old logistical problem in which you've got multiple, essentially what happens is that you've got multiple different entities, all of which have to take a singular action. So how do they achieve a consensus? How do they actually achieve commonality in their actions? That is what really the Byzantine generals problem is. So blockchain solves this problem by creating a consensus of shared, replicated, and synchronized digital data that is spread across multiple sites, multiple institutions, and multiple countries. What this means is that there is no central administrator at all. There are no central data storage facilities. It's spread across several nodes on a peer-to-peer network. It's spread across several devices on a peer-to-peer network. Each one of these nodes, each one of these devices will replicate and save an identical copy of the ledger and update itself independently. With every update, each node then constructs a new transaction. Again, remember, each node will replicate and save an identical copy of the ledger and update itself independently, which means that each node has a separate copy of the transaction. Again, so if I want to go and break into each of these ledgers, that's going to mean I have to infiltrate all of these nodes that have a record of this copy. Each of these nodes then vote by a consensus algorithm on which copy of the dataset is correct. All the other nodes then will update themselves with this new correct copy of the ledger after the consensus has been determined. Now that, again, is the hardest part, determining a consensus, and that's what really blockchain excels at. And again, remember, blockchain is not necessarily a breakthrough technology on of its own. It's an implementation of a larger technology, which is distributed ledgers, right? Blockchain is just a type of distributed ledger technology. So that's something you need to really remember. Frankly speaking, blockchain has already seen its heyday, and there are other DLTs that are coming out that will eventually take over blockchain. So again, that's something for the future. So when we're talking about blockchain, there's different properties that are involved within the blockchain, within actually every DLT. It is distributed, which means that all network participants have a full copy of the ledger for full transparency. It's anonymous, which means the identity of the participants is either pseudonymous, which means it's a fake name, right? It's not representative of a real identity. Or it could be anonymous, which means there is no identity involved at all, right? Either pseudonymous or anonymous. There's a key difference between the two. Anonymous simply means there is no record of who you are within the financial institution, within the financial system. Pseudonymous means there is a record of who you are, but it's a fake record. It's a made-up name, like a pen name almost. All of these transactions, although time-stamped, which means there is a record of the moment each of these transactions was made, a record of the moment each of these transactions was verified by multiple parties. It's unanimous, which means that all the network participants agree to the validity of each of the records. It's programmable, and we're going to look at that into a little more detail later on when we talk about smart contracts. It is secure, which means all of these records are individually encrypted, because that's what we're using. We're using cryptography to secure all this. And at the very end, and perhaps the most important of blockchain, is that it's immutable. What does that mean? It means that any record that has already been validated is irreversible and cannot be changed. So once you have validated record, once it's put on the blockchain, it cannot be changed. That really does give us a lot of security, but it does lead to some issues as well. Say, for example, how do you correct errors once they have been already recorded? So that's something that you have to look at later on. Further, we need to consider the different factors that affect the implementation of blockchain. At the very core are the governance issues, as have already been previously talked. You need to consider whether we're talking about private or public distributed ledgers. You have to consider who the trusted parties are. You have to consider who the organizations are. You need to figure out who the responsible parties or responsible party within the entire system is going to be. You need to look at it larger from an operational perspective. You need to figure out the access levels. You need to figure out the protocols for onboarding and offboarding of the different nodes, different entities within the blockchain. You need to figure out the methodology for validating data, the methodology for correcting erroneous entries. You'll need to consider the difference between digital and traditional assets. You'll need to consider the risk of tokenization of assets. And you'll also need to consider the transparency rules. And this is really all within the operations subsection. The largest on the outside would be the regulations, the net capital rules for digital assets, the physical location of the digital records, the possibility of and the effects of a cyber attack on the digital records, the settlement of digital records, privacy and risk, anti-money laundering, know your client, compliance. All of these factors will need to be considered when you're trying to implement a blockchain. So when we're talking about blockchain itself now, the most common application of blockchain is what's known as cryptocurrencies. Everyone, I'm sure, has already heard of things like Bitcoin. That would be an example of a cryptocurrency. Again, a cryptocurrency is simply a digital asset that can be exchanged with no physical form or shape, right? So the crypto part stems from the use of cryptography for security and verification purposes during these transactions. Now, as you would know, the process of converting plain text into unintelligible text and vice versa is known as cryptography. Combining the two, cryptocurrency becomes a medium of exchanging values in a digital form that relies on encryption, making the transaction secure. Again, I repeat that. Cryptocurrency becomes a medium of exchanging values. That's where the currency part comes from. In a digital form that relies on encryption, making the transactions secure. Cryptocurrencies can be considered an alternative to the ordinary payment methods such as cash, credit cards, or checks. Excuse me, that's my clock. It is 9 o'clock here. I'll just let it play out for a second. Right. So again, cryptocurrency can be used as an alternative to ordinary payment methods like cash, credit cards, or checks. Blockchain, then, is the platform which provides this cryptocurrency transactions to take place directly without the involvement of third parties, without the involvement of intermediary entities, which means a buyer and a seller can interact, can conduct transactions over long distances, over different multiple systems, over different multiple financial systems, right? And that's really the advantage of cryptocurrencies. So again, when we look at it, Bitcoin, that you have all heard, is a subset. It's a type of a cryptocurrency. Cryptocurrencies themselves are based on what's called blockchain technology, and blockchain itself is an implementation of distributed ledger technologies, right? So this is very important that everyone understand the difference between them. They're not different things. One is just the implementation of another. Blockchain is an implementation of DLT. Cryptocurrencies are an implementation of blockchain. Bitcoin is an implementation of cryptocurrencies. So that's where the hierarchy really lies. The next thing I'd like to talk about is what's called smart contracts. Now, smart contracts, now normally what happens with contracts is that there is a certain contract made between two parties, and then it falls upon one party or another to enforce those contracts, the terms of those contracts. What happens with blockchain contracts is that neither of these parties has to enforce. These are self-enforcing contracts. So, for example, we have an example here of a car insurance claim. So a car gets into an accident, right? That's the first step. So in order to control the claims costs, smart contracts are used to enforce rules where the insured person can spend that money on. We move on to the next stage where the customer is then directed to an authorized garage where someone will inspect the damage and post the details and repair estimates to the blockchain. Other garages will then confirm whether this person is saying the right thing or the wrong thing, and based on consensus, they'll agree, okay, what they're saying is right. That claim will then go on to the filing stage, where it is automatically initiated. The cover is verified and the repair is approved or not, depending on what has been said. This really helps us with fraud detection. because all of these garages within that area are connected on the blockchain, which means that if you go to one particular garage and claim make a claim on your insurance, you can't go simultaneously to another garage and make a claim on the insurance because these are already now connected, which means that there are no duplicate claims that can be made. Right? Final stage, once the garage has received the approval, it pays the vehicle, confirms this, the cost, everything is put on the blockchain, and the claim is settled automatically, which means imagine not having to make a phone call every time you get in a small car crash and having to wait an hour on hold for someone to try to figure out exactly what to do. All of this will happen seamlessly, automatically. You won't have to do it. This really does help reduce the claims processing cost. No human involvement is necessary at the insurance end once the smart contract has been created, because the entire contract will self-govern, will self-implement, will self-enforce. Right? So that's one major use case of blockchain. Another major use case of blockchain is where it comes to AML, anti-money laundering. Now, anti-money laundering really overlaps rather with the compliance aspect. So say, for example, in this case, we have a client who engages a broker, and the broker themselves works with multiple underwriters. Now, what happens in this case is that you've got multiple participants that are involved, and each of them are doing the same verification along the chain. Now, because all of these underwriters are performing the same verification, that's going to save time and cost, because now you're going to have a unified structure behind this entire distributed ledger. This distributed ledger-based certified file transfer utility will contain the client's key information that has been validated by each player in the insurance lifecycle. The client can provide the appropriate subset of keys for the next business partner, and the business partner can rely on the validation done by those in the chain previously without any delay. So as a result of this entire thing, we minimize the risk of committing identity fraud because all the entities are already connected to each other, and because of the reduced risk, the rates will also be lowered. Remember, there's an indirect relationship between risk and return, right? Between risk and the cost. The higher the risk, the higher the cost. The higher the risk, the lower the return, right? So you need to really consider that. Sorry, the higher the risk, the higher the return. So once you lower down the risk involved in any financial transaction, that is the key thing here. Once you lower down the risk involved in any financial transaction, you will end up with much lower cost of conducting the financial transaction itself. Right. So these are a few things that we really cover in our FinTech graduate certificate. Now, I wanted to talk a little more about the advantages of using distributed ledgers or blockchain within the context of compliance. One major advantage is that you go through an enhanced customer experience through only having to submit documentation once. Because that makes it much more efficient, you also end up with a lot more security because there's less opportunity for identity theft, which is a growing concern these days. And fewer transactions are being flagged as false positives, which is another major cost that you accrue over the time. In due course, the digital identity could be used across many different identities, many different industries, and not just for financial transactions within that particular context. It also helps with reducing costs, or operational costs rather, for banks through not having to run compliance check with every customer. If they've already been checked and given a digital identity, then you won't really need to go through that entire process every time they apply for a transaction, because it's already automatically set. And fewer operational staff will therefore be necessary for handling false positives. There will be increased security through the real-time distribution of updated compliance documentation, verified digital identities, and our opportunity to share in the real-time fraudulent transaction details. And lastly, there will be increased transparency for regulators, as both the immutability of the blockchain and the opportunity for the regulators to have nodes on the blockchain networks support the ability to get a full, transparent audit trail of all the transactions. So there's quite a few advantages of using distributed ledgers and using blockchain within the compliance context, but there are a few challenges that you have to face as well. The biggest challenge comes from privacy. Corporations will not want all of their customers or even their competitors to see their compliance documentation or digital identity if they don't have a relationship with them. Competing organizations will not want to share their user information because that really lowers the competitive edge. Similarly, when a corporation wants to exit a relationship with a certain financial institution, they will want the right to be forgotten entirely. How many of you have almost considered that all the details that you have on your Gmail, on your Facebook, or such things will be stored forever. So even if you leave Facebook, even if you leave Gmail, your data will still be there. So that is something that is a major concern to major corporations, is that once they leave the blockchain, will they be forgotten, or will their data still be kept for others to see? And that's something that's really a major challenge when it comes to the implementation of blockchain, of distributed ledgers in the compliance context. You also have to consider the liability, right? If one bank verifies a customer through compliance check and that digital identity is then used by a different bank, who will be liable? Who will be responsible in the event of a fraudulent transaction by that customer? If bank A, if financial institution A, confirms the digital identity of an entity, of a customer, and that customer turns out to be fraud and has committed fraud across multiple other financial institutions, who will take responsibility for that fraud himself? Who will be taking that charge? So that's something that you really need to consider. How frequently should customers be re-verified, and who will be responsible for that re-verification? Will it be the same entity that issued the digital certificate, or will it be some other entity? You'll also have to think about factors like standardization. As in, all banks within one jurisdiction are required to conform to the same compliance rules and regulations. So standardization within this domain is relatively simple. However, when you're talking about financial institutions over different financial systems that use different jurisdictions, that have different rules, different regulations, how will you standardize between them, right? If you're talking about different banks within Canada, each of them will be able to easily work together because they're all working on the same financial system. But if you've got a bank in Canada, you've got a bank in the UK, you've got a bank in India, you've got a bank in Japan, how will these ones work? Because the financial regulators are very different in all of them. How will they be standardized? So that's really something that you really need to consider. That's a major challenge right now. Secondly, the standardization of banks on onboarding checks relating to their own risk appetite and customer filing will need to be considered. Lastly, I'll need to consider about a single point of failure. The creation of a single global compliance identity for blockchain, would that not allow us to virtually create a target for hackers and cyber terrorists? Remember, it's harder for hackers and cyber terrorists to attack an identity, to attack an institution, if the data has been spread out, if it's decentralized. Now, again, we talked about decentralization earlier on. Decentralization itself can be considered of two types. You can have what's called logical decentralization, and you can have what's called physical decentralization. And the two are not mutually exclusive. Logical decentralization simply means that there is only one entity governing, in charge of the data collection, of the movement of all the data. Physical decentralization simply means that the data is spread over different areas. It's kept in different facilities, right? So you can have a single entity that collects all the data, but stores it over different places. But then if all of these entities, they are decentralized, but if they're storing all of that data in one place, in one blockchain, does that not make it liable to get hacked? That's something that really is a challenge of DLT. So we cover topics like this and others in what's called our FinTech Graduate Certificate. Now, it's an 8-month program that is offered on site, and with the advent of COVID, we are quickly moving to an online platform as well. So if you are interested in more details about blockchain or other FinTechs, please look this up. Our curriculum is spread into 2 semesters. First semester, we talk about things like financial services and products. We talk about privacy management, identity theft. We talk about blockchain, DLT, and cryptocurrencies. We talk about financial services, regulatory landscape, and RegTech. RegTech, again, is an implementation. It's a fintech, regulatory technologies. We talk about business analysis, and we talk about cybersecurity, which is rather important. In the second semester, we move on to web and mobile design fintech. We talk about entrepreneurship and startup strategies. We have data analytics, and we end it all with the capstone project. So that is the entire fintech program. If you are at all interested in knowing more, please look this up. If you have any questions also, please email me at ishan.srivastava@sendcollege.ca. I'm afraid I don't really have too much time to answer your questions right now, but this is my email. So if you have any questions, please email me, and I'll be happy to respond to you. Other than that, I think I am done with my presentation for today. Thank you very much for listening in, and I hope this has been useful for you. Good luck, thank you, and good evening.
Any questions there?
Again, any questions that you may have about this, I will be sending this presentation so you can look at it later on. But again, as you realize, this is a very skeletal presentation. The crux of the details, those I can answer in much more detail if you email me. All right. Okay, so if that's that, I will take your leave. Thank you for listening, and I hope you all have a very good evening.
Thank you, Mr. Ishan. Bye-bye.
Thank you,
Goodbye.
Ishan sir, for your this interactive session.
Thank you.
Thank you.
Thank you, Ishan. We'll be in touch. Atul here.
Okay, thank you. Take care.
Thanks. Yeah.
Okay. Atul sir, tomorrow morning we will have one short meeting
Yeah, sure. I think let the
with
participants.
Ashok sir. With Ashok sir for discussing remaining sessions and these further sessions.
No, we have a clear idea on all the further sessions. See, what we are having.
No. Further remaining parts. I'm not talking about this session. I'm talking about
next.
second and third slot.
Yeah, that we could discuss over mails also. That's not a problem. Because tomorrow,
Okay, sir. No problem. No
yeah,
problem.
at least for the participants, I think for tomorrow we have the DevOps session again from 2 to 4.
Okay.
And then 5 to
Okay.
7, we have sessions with Kiran Vaidya and one more person from US, Ed Bukchi. He is from Coinbase. So we will he will talk about those hackathons and other details that you can do hands-on. And Kiran Vaidya, I think, is going to talk about Ashok. You have an idea?
Yeah.
I forgot. He's going.
You can text me, sir. You can text me. No problem, sir. You can text me so that accordingly I will prepare the schedule, just like I prepared today.
No, we have it on the file. We have it.
I've already sent you on WhatsApp, but
From Ashok sir, I received Atul sir sessions. I need to add over there. No problem. I will add it.
No, I don't have any session tomorrow.
No. That first session.
2 to 4.
2 to 4 is DevOps.
DevOps. Yes.
So Prakash will be continuing with DevOps. He has specific plans as per the ones we have shared earlier.
Okay.
So 2 hours will be DevOps 2 to 4, and evening session there will be 2 persons from Canada. So that's what Ashok was trying to explain. What Kiran Vaidya will be covering.
Yeah, 5 to 7 will be startup opportunities in blockchain by Kiran Vaidya. And
Okay. Very good.
and 6 to 7 will be Ed Bucci. He will cover 3 different aspects of ecosystem, and that is the how to form the communities and the role of the communities in the blockchain skills development. Then about the hackathons and about the bounties, and yeah, so basically those 3 things he will cover. So that will be from 6 to 7.
And Ashok, you want to tell about day after tomorrow when they have the exam or quiz and 1 hour session?
Yeah, and day after tomorrow, before the exam, we will cover as to what all the faculty members will be able to do in future following up of this particular course was basically just a very high level introduction to the whole blockchain technology concepts. Actually, what all they can do subsequently, like, which courses they can introduce in their colleges, where are the opportunities for higher education, what are the opportunities, how they could help the students to form the startup projects, what kind of research work they could take up, and how they can organize for that. I mean, already many things have been already told to you, but how we can actually organize and implement it in your colleges. This is something what we can deal with for a short period of about, I mean, between me and Atul will take about 1 hour or less than that prior to the final exam.
Sir, I will be really appreciating your efforts you are taking. Could you share some kind of a documents that what we discussed regarding MOU so that before last day we can have a MOU on behalf of SVERI with your organization.
Sure. Certainly we can do that. Yeah.
So that I will be put with proudly as an outcome of this STTP.
Oh, yes.
And that will be a sample for all the participants, because for this STTP, we
Yeah.
have more than 40 participants from various corners of India, sir.
Yeah.
Wow.
And various colleges are there. So we
Excellent.
can show them.
Yeah.
That's very good,
Okay,
Tigran, sir. And I would definitely say that tomorrow's session is important for all the participants, that Ed Bucci is going to talk about hackathons and the global communities. And if you want to be a part of those global communities, because that is where the best of the knowledge is, and Ashok Ranade can help us connect with them, because he is at Canada an active member of many of those communities and he knows those people very well. So we should
Yes,
take
sir.
advantage of that and work with Ashok Ranade sir to get all people onboarded on that, or boarded up on that community. Then they should start really actively doing something.
Yeah.
Yes. I must say it. Thank you, sir. Thank you all. Thank you.
Thank you.
Okay, thank you.
We'll take a pause here. Tomorrow, exactly at 2 p.m., we will start the session. Thank you
Yes.
once and all.
Okay. Thank you.
Okay, bye.